Understanding fever, nature's defense mechanism. Fever is an unpleasant experience. When we have it, we often turn to medication to suppress it. But is this always the best approach? Fever is one of the body's oldest defense mechanisms against illness. What exactly is fever? How does it strengthen the immune system? And should we always take medication to reduce it? Life on Earth exists within a temperature range, thriving between extreme conditions. Some forms of life endure temperatures as low as 10 degrees in deep, cold waters, while others survive in extreme heat, reaching 120 degrees near thermal vents. However, moving beyond these limits is lethal. Every organism has an optimal temperature range where it functions best and a tolerable but stressful range where survival is possible for some time. Humans, as warm-blooded creatures, maintain a stable body temperature around 37 degrees, 98.66 degrees, expending significant energy to do so. While maintaining a constant temperature may seem wasteful, it provides an important advantage: protection against certain pathogens, particularly fungi. Many cold-blooded animals suffer from fungal infections, but humans, with their relatively high body temperature, are resistant to most fungal diseases. This leads to an important question: what role does fever play in protecting the body? Fever acts as a defensive climate shift that disrupts invading pathogens by pushing them outside their ideal temperature range, making the body's environment inhospitable for them. This response evolved at least 600 million years ago and is found in many species. Various animals exhibit behaviors that mimic fever to raise their body temperature when sick. Fish seek out warmer waters, lizards bask in the sun, and bees increase the temperature inside their hives to combat infections. Mammals, however, have even more drastic physiological responses to infections. When an infection occurs, bacteria and viruses invade the body, and the immune system must act quickly to slow their spread. Fever is part of the body's first line of defense and is triggered by a group of chemicals known as pyrogens, which literally translate to creators of heat. These molecules travel through the bloodstream to the brain, where they signal receptors to increase body temperature. As a fever develops, the body undergoes several changes. The first noticeable response is shivering, where rapid muscle contractions generate heat. Simultaneously, blood vessels near the skin constrict to prevent heat loss, making the skin feel cool while the body's core temperature rises. Fever is a systemic response, requiring a significant energy investment. For each degree Celsius of increased body temperature, the body's metabolic rate rises by about 10%, consuming more energy. Additionally, fever signals the body to rest, conserving energy for the immune system to fight off infection. At the infection site, bacteria attempt to multiply rapidly, requiring vast amounts of resources. However, fever introduces additional stress. In response, the immune system increases inflammation, sending fluids, proteins, and immune cells to the battlefield. The rise in temperature creates a harsh environment for bacteria, damaging their membranes, disrupting their DNA, and inhibiting protein production. This intense heat is harmful to bacteria and viruses, making it more difficult for them to survive and replicate. While fever places stress on pathogens, it also affects human cells. Every organ system functions less efficiently during fever, except for the immune system. White blood cells, such as neutrophils, macrophages, and dendritic cells, become more active, improving their ability to identify and destroy pathogens. Additionally, fever causes immune cells to restrict access to critical nutrients such as iron, glucose, and glutamine, further weakening the invaders. Viruses are especially vulnerable to heat. For instance, the rhinovirus, responsible for the common cold, primarily infects the respiratory tract because it is cooler than the body's core. When fever increases body temperature, infected cells experience extreme stress. In response, they produce heat shock proteins, HSPs, to protect themselves. However, this response has an unintended consequence. It signals immune cells that these cells are under extreme distress, leading to their destruction. Natural killer cells and T cells are drawn to the HSP signals and eliminate infected cells, preventing the virus from spreading further. Given the effectiveness of fever, why haven't pathogens evolved to withstand it? The answer lies in the balance between adaptation and survival. If a pathogen adapts to fever, it becomes less suited to infecting healthy individuals with normal body temperature. This evolutionary trade-off forces most pathogens to remain susceptible to fever. Some highly infectious diseases, such as measles, use a different strategy by replicating quickly and spreading before the body's full immune response, including fever, can take effect. If fever is such a powerful defense, why do we take medication to lower it? Modern pain relievers and fever reducers, such as ibuprofen and aspirin, have only been widely available for about a century. Before that, managing fever was not an option for most people. While these medications can provide relief, they may also interfere with the immune system's ability to fight infections effectively. Pain is an essential signal that tells the body to rest and conserve energy. Fever is closely linked to pain, and many common medications that reduce pain also lower fever. This is particularly true for children, where concerned parents and doctors often seek to reduce fever, sometimes mistaking it for the illness itself or worrying about potential harm. In most cases, fever below 40 degrees, 104 deep, is not dangerous and does not require treatment. However, certain individuals, such as pregnant women, elderly patients, and those with weakened immune systems, may be more vulnerable to the stress of fever. When fever exceeds 40 degrees, it may indicate a malfunction in the body's temperature regulation and can be dangerous. There is evidence that for some illnesses, such as influenza or chickenpox, fever-reducing drugs do not necessarily speed up recovery. In some cases, suppressing fever may even be harmful. One study in critical care patients showed that aggressively lowering fever led to higher mortality rates, prompting researchers to reconsider the role of fever management in severe infections. Despite these findings, there are cases where reducing fever is necessary, particularly in individuals with neurological conditions or those at risk of complications. More research is needed to fully understand the trade-offs between fever management and immune response. So, should you take medication to reduce fever? The best approach is to consult a medical professional rather than relying on generalized advice. If the fever is not dangerously high and you can tolerate it, allowing it to run its course may support your immune system and lead to a quicker recovery. However, if you feel extremely unwell and need relief, taking medication can provide comfort, though it may slightly reduce the immune response's effectiveness. Ultimately, fever is a sign that the immune system is fighting off an infection. The next time you experience it, you can take comfort in knowing that while you may feel unwell, the pathogens attacking your body are facing an even greater struggle. Thanks to scientific research and medical advancements, We now better understand fever's role in immunity, helping us make informed decisions about when and how to treat it.